Hi, I'm Ranger Rhonda, and normally I would be welcoming you to Great Smoky Mountains National Park, but today is just a little bit different. This is a video series where we'll be exploring natural spaces right where the Smokies park rangers, park staff, and park partners live. So I invite you, come enjoy an outdoor experience with us in this episode of Smokies at Home.
Hi, welcome to our Smokies at Home exploration. I'm Ranger Janine from Great Smoky Mountains National Park. I'm playing in my neighborhood, and today I want to learn about shadows.
Shadows are curious things, aren't they? They follow us around no matter where we go. Mostly. Sometimes they walk in front of us. And sometimes they walk behind us. And they can be big or they can be small. And if you take one up a step, well, it can get a bit funny. But have you ever really studied your shadow and tried to figure out why it is the way it is? Today, my kids and I are exploring our shadows together. Why don't you join us? If you look at your shadow, what do you notice about it?
That it's almost exactly the same as you, it's just black instead.
That's all black?
Now, when you look at a shadow in an illustration in a storybook, it's often black or gray or even purple. Do you think it's actually black or gray or purple? If you look at it carefully?
It's sort of when I look at my shadow, I think it depends on what it's on.
Okay.
Right
So
now it looks sort of green.
that one looks kind of green. Which side of you is your shadow on?
Our front side.
It's on your front side. Is it always on your front side?
Anyway, look, I just turned.
It could be any way if you turn. So if you were going to tell somebody where to find their shadow, what would you tell them?
It's like if you find the sun in the sky, then it's always going to be on the opposite side of where the sun is.
Right, so our shadows are just the places where the sunlight doesn't reach because it's blocked by our bodies, which means that where the sun is in the sky can change how our shadows look. And it also means that how our shadows look can give us a clue about where the sun is in the sky. Based on what you've observed in the past about your shadow, can you make any predictions about how it might change over the course of the day?
It could get shorter and then longer again.
When do you think it would be the shortest?
At noon, because then that's when it's most over you.
We're going to find out if you're right. And to do it, we're going to track two things, our shadows and the sun. Now remember, you should never ever look directly at the sun. It's so bright that it could permanently damage your eyes. We're going to track the sun not by looking at it, but by using shadows, of course.
We're going to have two experiments going, and we're going to check in on them a few times during the day. First, we're going to observe our own shadows and see how they change over the course of the day. If you'd like to do this activity with us, you can find the directions on the Smokies at Home website. There are a few ways we can do this activity. We can trace our shadows or mark the ends of our shadows with something we pick up, like a stick or a rock, or we can track the shadow of something other than ourselves, maybe a flower or a feather that we stick in the ground. We're going to use our own shadows, and we're going to mark them with chalk. And since we don't want to stand in the same spot all day, the first thing we need to do is mark exactly where we're standing so that we can come back to the same spot each time. We're going to do that by tracing around our feet. We're also going to need to trace around our shadows so we remember what they looked like to start. We're even going to label them with the time. It's 9:07 right now, so we're just going to write that right in the shadow.
We also want to track the path of the sun through the sky. Now the directions for this aren't written up on the Smokies at Home website, but if you want to try it at home, you'll just need a glass bottom bowl with a rounded bottom and a window marker or a grease marker to write on it. Now you need to make sure that whatever you're writing with will really wash off the bowl later, so make sure you check with your grown-up before you try this activity. If I were laying on the ground looking up at the sky, I could see out to the left of me and to the right of me. I could look way up above my head or all the way down past my toes, but I couldn't see anything that was behind me because the earth would be in my way. This bowl is going to represent all the different parts of the sky that I could see if I was laying on my back. Just imagine tiny me laying here on the grass under the middle of the bowl looking up at the clouds above me. But remember, tiny me is looking up at the clouds, but neither of us should be looking at the sun. To help you to remember that, I'm going to replace tiny me with a tiny ranger hat, so that the sun is on the tiny hat and not in my tiny eyes. We're going to record where in the sky the sun is without looking at it. I'm going to show you how. Just like with our shadows, it's important that this bowl stays the same direction relative to the sun. Now ideally, I'd put this bowl in one spot and I would track the sun from there all day long. But I don't have a spot in my yard that stays sunny all the way from sunrise to sunset. So I'm just going to make sure that I always have my bowl face the same direction. In my house, north is that direction. So I'm just going to place my bowl here on the ground, and I'm going to mark a spot on the bowl that tells me where north is, so that the next time I put the bowl down, I can make sure that my bowl is still facing towards the north. Now I need to record where the sun is in the sky. Remember, the sun is always on the opposite side of an object from where the object's shadow is. I'm going to use the shadow of the pen that I'm writing with to figure out where the sun is, and then I'm going to record it on my glass bowl sky. To do that, I want to hold the tip of the pen near to the bowl, but not touching it, and move it around until the shadow of the pen tip falls right in the middle of my mini ranger hat. Then when I found the right spot, I'm just going to make a dot right on the bowl. And I want to remember what time it is, so I'm going to write that on the bowl as well. It's about 9:30 right now, so I'm just going to write 9:30 by the dot that I drew on the bowl. And that dot is right where the sun would appear to me if I was tiny and standing in the center of the bowl. So how do you think the sun will move through the sky?
Okay, well, since this is where it was and the sun was about here, it'll probably go over and then come back down, like, you know, and this will be like noon and like that. And it might even go a little bit off to the side since, you know, we're not right on that line.
Okay, so you think that at noon it'll be at the very tippy top of the bowl?
Yeah, but like it might be off to the side because we're not right on that, like the equator.
Okay, do you agree?
I think maybe it won't be quite up here in the middle. I think it's more gonna go upwards, maybe get up here, then go downward.
So let's make a prediction about how we think the sun will move through the sky, and we can mark our prediction on the bowl in a different color. If you girls have different predictions, we can mark them both on the bowl.
It might go a little bit, it's kind of hard to draw up there, but like that.
All right.
That's fine.
All right, so you both have where you think the sun is going to set?
Yeah, I think the sun's gonna be setting over there.
All right, and you think the sun is going to be setting where?
Over here, down here.
All right, so we're going to find out. That's it for now, and we will check back in a couple of hours. Okay, so here we are back outside, and we want to check in on both of our experiments. Let's start with our shadows.
I can already see mine when I'm walking and it seems shorter. What do you think?
Yeah, mine's a lot shorter.
All right, let's trace our new shadow and see if we're right. Yeah, look at that. It's definitely a lot shorter now, and it's not in the same place as it was earlier. How does it compare to the prediction that you made?
Well, like it did get shorter, but it also moved to the side a little bit.
Yeah.
You think it'll keep getting shorter all the way until sunset, or you think it'll get bigger again?
I think it'll get bigger
I think
again.
it'll be at its shortest at noon, and then it'll get bigger again, and then it'll get like really long.
But we aren't done yet, are we? We were also tracking the sun. Let's go take a look and see what was happening with that experiment. We also need to record where the sun is in the sky. You remember how we did that, right?
Yeah.
Can you guys do it and explain how you're doing it while you do?
So basically, what you do is you need to line the point of the pen up so that its shadow is right at the very middle of that reindeer hat. And so then you put a dot there, and that's how you track the sun.
All right, and we can already start to see how the sun is moving through the sky. It was here at 9:30, and now it's 11 o'clock, and it's already moved to up there. Is it following the path that you predicted
Sorta, yeah.
so far?
It looks
pretty
like
good.
it could go either way because I think that it's going to go that way, but she thinks that it's going to go like that. And really, it's at that point, so we don't really know yet.
All right. We're going to speed things up a bit. Let's see what happened when we checked in on both of our experiments. So we checked back on our shadows at about noon, and we could see that they were continuing to change. And then we checked back at about 1 o'clock, and our experiment was completely in the shade, so we had to stop tracking at that point.
It looks like we don't have any sun anymore, so we can't do any more shadow tracking, which means if you're going to do the shadow tracking, you're going to have to kind of continue on alone to see where your shadow goes from here, whether it continues to get smaller or if it starts to get bigger at some point, and see how far around the circle it might even go.
We also continued to record the sun's location on our sun tracker bowl all afternoon. We even had to move the bowl a few times to keep it in the sun so that we could track the sun all the way through the afternoon and into the evening. We were planning to track all the way to sunset, but here's what happened.
So I thought we'd get one last data point yet this evening, but the sun went behind the trees before it actually reached sunset. So we aren't going to be able to get another one tonight, but let's take a look at what we saw. You can see the arc of where the sun went starting at 9:30 this morning, and then we have data points going up at 11 o'clock. We have several in the afternoon going all the way till 3 o'clock, and then down the other side, and the last data point that we collected was at 7 o'clock. So we can actually draw a line through that will help us to envision what the path of the sun through the sky looks like. What can you girls tell me about it? Did it go where you thought it would go?
It sort of went in between.
Yeah, it was kind of in between our two guesses. And it was a pretty smooth arc.
Yeah.
Except for some drawing errors. But yeah, it went pretty smoothly, and you can see that this would make sense that it rose, it got it to its peak, and then it went back down again.
Yeah.
Because that's how the sun goes in the sky.
I think we've learned some things about the sun today, and we've learned some things about our shadows, but maybe you have some other questions that you're curious about. One of the things that I've been curious about is how the path of the sun might look different in different places. And one of the things that I realized is that with national parks and national wildlife refuges all across the country, I could probably get some help figuring that out. I had help from rangers in parks and refuges from Alaska to the Virgin Islands. And in a moment, they're going to introduce themselves and share their bowls with you. When you're looking at their bowls, I want you to watch out for a couple of things. First of all, I'd like you to notice how high the sun's path goes in the sky.
I noticed that in some of their videos that sun's path went all the way up towards the top, and in others it stayed well below this ridge line and kind of the sun moved through the sky at a lower angle. They're also going to be telling you about what time sunrise and sunset were in their location. I'd like you to think about how day length changes with latitude, with how far north or south you are located relative to the equator. The first ranger that we're going to meet is in Kenai National Wildlife Refuge, way up north in Alaska. Then we're going to work our way across the latitude lines until we make it all the way to our farthest south ranger in Virgin Islands National Park. The rangers that helped me with this activity collected their bowls on different days over about a 3-week time period because they had to wait until they had a sunny day in their location. To help you compare the day lengths, I've added the sunrise and sunset times for each location on one single day, May 1st, 2020, in the text at the bottom of the video.
Hi, Ranger Leah here from the Kenai National Wildlife Refuge in Kenai, Alaska, 60 degrees north latitude, and I tracked the sun from 8 a.m. until 8 p.m. 10 p.m. was my sunset, but the tree shadows got in the way for the last 2 hours of this experiment. Have a great day.
Good morning. I'm Ranger McCat Clark, and I work at Acadia National Park. I started measuring on May 7th at 5:12 a.m. the sunrise and ended at sunset 7:48 p.m.
Hi, my name is Mary Beth from Wind Cave National Park in South Dakota, and I tracked the sun from 5:40 a.m. sunrise to 8:01 p.m. sunset on May 5th, 2020.
So this is where the Smokies fits into the sequence. This was, of course, the bowl that we tracked together, and our sunrise was right around 6:45 in the morning, and our sunset was about 8:20 at night.
Hi, my name is Alana. We're here at Virgin Islands National Park on the island of St. John in the U.S. Virgin Islands. We're tracking the sun from 7:45 this morning to 3:45 this afternoon.
I'd like you to stop for a moment and think about what you expect Alana's finished bowl will look like. Do you think that the sun will pass high overhead at its peak, or do you think it will move through the sky closer to the horizon? You may want to pause the video here for a moment while you sketch down your predictions. Now, compare your prediction to Alana's finished bowl. Were you right? Why do you think the sun passed so high overhead in the Virgin Islands? It's something to think about. I hope you had fun tracking the sun with us today. There's so much to learn, and there are lots of other activities on the Smokies at Home website. We hope you'll keep discovering things with us. Stay curious and have a great day.